Welcome everyone to Our Ladies Room. This is our first story event for for 2004. I'd like to remind you that a bit of housekeeping. This talk is recorded and will be posted on YouTube on our channel at Our Ladies Room. So if you don't like to be recorded, just feel free to turn off your cameras. We do this to prioritize creating a safe and inclusive space, free from any form of harassment, fostering a respectful environment for everyone to learn and connect. We have a code of conduct, so please be respectful. If you like to have a look, it's at ourladies.org/COC/. So if you like to use the chat, you are very welcome to chat with the others here and ask questions. And then I think you can just raise your hand and allow you unmute for asking questions. Material for today, you find everything in the chat. But in the meantime, I do this introduction. Please make sure to head over posit.cloud, sign in, and follow the link in the chat for the workshop material. If you experience any issues, please put one in the chat so we can help you out. As I said, this is the first story event of 2004, hosted by Our Ladies Room. Introduce myself. My name is Federica Gazzelloni. I'm Italian. I'm from, and I am one of the chapter organizers. I'm thrilled to have you all here. We have also our new co-organizer, Silvana Cosa. I don't know if you would like to introduce yourself a bit. She just joined us.
Thanks for the welcoming. Yes, I just recently joined. I'm based in Barcelona. And yeah, I work as a data scientist in tech now.
Thank you. We are also delighted to be joined by Shannon Pileggi, who will be our speaker. I'd like to talk a bit about Our Ladies. Our Ladies is a global organization with the mission of promoting the art language for empowering women at all user levels by building a collaborative global network. It's a friendly community founded in 2012 by Gabriela De Queiroz in San Francisco, and it is now a worldwide organization with more than 219 chapters in more than 63 countries with many events, many members. If you'd like to have a look at the Our Ladies Global website, you can find it here at ourladies.org. What is Our Ladies Room? Our Ladies Room is part of Our Ladies Global, and it is as well dedicated to promoting gender diversity friendly in the art language community. We do monthly meetings, more or less once a month, but even twice somehow, if it's the case. And we do that to provide a platform to discuss current trends and hot topics in art, to share some common interests and encourage active participation from all attendees. As well as we welcome your suggestions, comments, and invite you to get in touch to join our vibrant community. The founder of this chapter is Claudia Vitolo. She is also the co-founder of Our Ladies Global. This is me, Federica Gazzelloni, and Silvana Costa. We also have a little Google form for you. I'll put it in the chat. If you like to join us, you can fill up the form and we will get in touch. That would be very so exciting to have you join us, our team. A little overview about the what to expect from Our Lady's Rome in the following months. So so far we already have had an introduction to Porto. A couple of days ago, we've been through artificial intelligence with building a chatbot with Shani and R. That was very amazing. And also, so the session for today, which is so getting inside R and solving issues with Shannon. We plan to have more events as these ones with Isabel Zipperman talking about Petiver and model deployment. Also, we will be joining Our Ladies New York in April with an event about causal inference. And amazing news is that we have Hadley Wickham, so the author of R for Data Science, the Tidyverse meta package, and so advanced R, and so many more, even mastering Shiny, talking for Our Ladies Room. Also in June, we expect to host an event with Janina Bellini Saibene, which is, she's the founder, I think, Shannon, is, if I'm not saying wrong, so of the R Open Science community. And then in the end of August, we expect to a great event with Julia Stewart Lawrence about NASA OpenScapes project, and much more. I don't know what's gonna happen. Okay, so I have a little slide for you. If you like to scan the code or use this debugging R code for getting inside the pool. I do this to have an idea of your level and where you're from, so we know each other a bit better. Okay, if you experience any issues, any problem, please ask for it in the chat. Are you all inside the Slido? You can just add to slido.com and type this #debugging R as a code for getting into the pool, or otherwise scan the QR code. I'll launch the pool. The first question is, which country are you joining us from? Thank you. United States, Belgium, India, Spain, Scotland, Germany. So we've given the time to everyone to log in and join us, even if it's a bit like difference of time, different time zone in the world. So here is 6 p.m. in Italy, but you know, we have all different times. Germany is like predominant within our attendees. France, Ireland, United States. I've think, yeah, okay. We have 16 responses. I think half of the people here. Do you need any, you need just to go to slido.com and then type hash debugging R as a code. You don't need to log in, nothing at all. Okay, I think I'm going to close this pool and launch the other one, which is what is your job role? Please feel free to write anything that you think is the most appropriate role for your position. Data scientist is the most postdoc, statistician, professor, PhD candidate, scientific associate, data visualization consultant. 19 responses, a bit more than before. Okay, lecture. Okay, or otherwise you can just scan this QR code here um, on the left side of this image. You can just scan the code and you will be redirected to the pool. Okay. Thank you. Yeah, I see something in the chat. Okay. I think I'll close this pool. And the last one is I would like to know is how familiar are you with debugging in R? Okay, so but we had 21 responses, so not 32 exactly. So we still missed about 10 people, yeah. But so far we have 15% completely green, and 41 some basic knowledge, and 9% has some solid background. So no one is an expert on debugging. Okay, so thank you very much. Let's go back to the last part of our presentation, which is just introduction. So welcome to this exciting event where we will be exploring the world of debugging in R. This will be an interactive session where you can expand your knowledge about R, learning code, troubleshooting tips, and everything. So welcome to Dr. Shannon Pileggi. She is a lead data scientist at the Prostate Cancer Clinical Trial Consortium, a frequent blogger, a member of the R Ladies Global team. She enjoys automating data wrangling and data outputs and making both data insights and learning new material digestible. You can have more information about her on our website as well, which is www.ppingotdata.com. Welcome, Shannon. Floor is yours.
Thank you so much for the introduction and for having me today. I love presenting this topic. You are certainly welcome to keep your cameras off, but to be honest, if you are at all able to keep your cameras on, it is a much more pleasant teaching experience for me to look at you rather than to look at some black squares. It really helps me to gauge like where people are stuck, but I completely understand if you need to take your camera off. So it's not a requirement by any means. So today we are going to be talking about debugging, and I'm already debugging Posit Cloud over here on the side on the chat. I guess the sharing link didn't work for everyone. So when we start entering Posit Cloud, if you still need access to that, I will do my best to access you, but I have been adding people individually from their email. So today we're going to be talking about just a couple of tips on troubleshooting, but we're going to really focus most of our time on formal debugging tools. And we're going to differentiate between debugging code that you own, tips and tricks for how to debug code in the RStudio interface, and then debugging code that someone else owns that you don't actually really have the source code for, or at least immediately at your fingertips, and then maybe some special cases. If at any point in this presentation you have a question, you are certainly welcome to drop your hand or put your question in the chat. I try to monitor it periodically and address those questions live or save them for the end, depending on the scope. So this work is licensed under Creative Commons license, and it was originally developed as part of a 2-day RStudio conference, now Posit conference workshop, called What They Forgot to Teach You About R. So if you see the WTF acronym in the slides or in the Posit Cloud workspace, that's where the acronym comes from. WTF stands for What They Forgot. And it falls under this because debugging is a pretty specialized skill in R that I don't think is traditionally taught in many curriculums. So if you're working locally, I'm going to be assuming you're working from a recent version of R and RStudio and that you're ready to build packages. However, we are going to try to use Posit Cloud and not be working on our own personal computers, so we should all have the same workspace set up. If after this presentation you're interested in learning more, there's a whole host of resources here. If I can highlight a few, like the debugging chapter in Advanced R is really good, and the Jenny Bryan 2020 RStudio Conf keynote is really fabulous, and I would highly recommend you watch it. And some of the examples we're going to be going over today are straight from that keynote talk. So before you get to any like formal debugging processes, you have this problem that where an error occurs in your code and you need to do some basic troubleshooting. And so the basic troubleshooting you should be doing before you get into formal debugging is first like searching, like if you hit an error you're unfamiliar with, you can search for that. And if you're not really familiar with like the best search practices, I recommend watching Teach Me How to Google, another R Ladies workshop by Samantha Fisk. Another really important concept is debugging is to reset R. And that means restarting R, especially when things get weird. And we're going to go over that in more detail on the next slide. And then lastly, a really great debugging tool is to create a reprex. A reprex is a minimal reproducible example, and it is one of the best ways to whittle down a big and complex and gnarly problem into something simple where you can really pinpoint the source of the error. And if you've never made a reprex, I highly recommend this talk by Charlotte Gelfand, Make a Replex, Please. But let's really talk about resetting, because this is such a huge component to debugging, and I'm going to be doing this over and over and over again as you watch me go through some exercises. So when you have a problem in R, it's really important that you turn R off and on again. There's a whole lot of like weird things that can linger in your workspace, or maybe you're doing some on-the-fly package installations, and there can be some interactions that are happening in your environment. So it's always best to start with a clean slate and rerun your script when you're encountering errors. So to turn things off and on again, there's also some really important background that you want to have appropriate settings in your RStudio interface. So to turn things off and on again, you can go to Session, Restart R, or you can use your keyboard shortcut. But before you do that, you want to make sure you have your workspace settings set appropriately. So you would go to Tools, Global Options, and then your workspace. And then when you see this, you want to have the following selected. Uncheck Restore Art Data into Workspace at Startup, and Save Workspace to R Data on Exit, Never. Now, this is very safe to do in your Posit Cloud environment because it's not your local environment. It's not going to interact with anything that you have going on. If you do it on your local computer, and I do recommend that you do it on your local computer, it will change what you see when you open R. So normally, if you don't have these options set, when you open R, you will see objects in your environment from your previous session, and they will still live in your environment. Now, when you open R, you'll open R with a clean slate, and there will no longer be these objects in your environment. So it is a different way of working, but a good way of working. So our first exercise, and you are welcome to ask questions about that in the chat as we go through our first exercise. But I want you to either on your Posit Cloud workspace or your own personal computer, and we need to do it on the Posit Cloud workspace anyway, is set your workspace options as shown. So I'm going to demonstrate that for you in the Posit Cloud workspace. And I'm going to move this over here. Going to go to debugging, open up my project. So again, the way we're going to get to those settings is we're going to go to Tools, Global Options, and then I'm going to uncheck Restore R Data, and I'm going to set this to Never instead of Always. I'm going to do that 2 more times. So again, we go to Tools, Global Options. If you scroll down in your global options, there's the workspace section. You will uncheck Restore R Data and save the workspace to R Data on Exit to Never. There's a question in the chat. Do you recommend to uncheck the workspace restore box just for debugging or in general? In general, always, because you are going to always be debugging, right? Like, when do you have a time that you're working in R that you are not debugging, right? Like, every time you hit an error in your code, this is a great way to start with a clean slate. So I would definitely recommend doing it always. So again, last time, we're going to go to Tools, and of course, if you need me to repeat myself, I'll do it. Global Options, Restore, uncheck Restore R Data, and set this to Never. And then importantly, what I have not been doing is hitting Apply. I've just been hitting Cancel, so I can show you again. So this time I'm going to hit Apply. So any more questions about this and why we're doing it and why it's important? or how it's going to change the way you work. Happy to take anything. All right, so this time I'm going to hit apply, so these settings actually persist in my RStudio environment, and then okay. All right. So you've done the things, right? You've tried searching your error, you tried restarting R, you tried making a reprex, and things still keep coming back at you. Like, what are your options now? And specifically, we're talking about in the context of functions. Like, so when you see an error or an unexpected result in a function, what do we do next? So for debugging your own code, and that means where you have written the function and you're leveraging it from sourcing it in or from a package, there are traditional print methods, and I'm not going to spend any time talking about how to like insert print statements into functions, but there's a good amount of that in the advanced R book. What I always did in the past, so I would like very painstakingly set and interactively run function arguments. Like, I would have a function with 5 arguments, and I would set each one individually, and then step through my function and be messed up between things in my global environment and my function environment and everything that was happening. It was a mess. So thankfully, there are more efficient tools available. And so when we talk about debugging, here are the key concepts we're going to discuss. We're going to discuss the traceback, as shown by the road icon, which is the location of where the error occurred. We're going to talk about use of the interactive debugger, which gives you context on why the error occurred, and that's got the ladybug symbol. And then we're going to be talking about debugging your own code, inspecting it with that magnifying glass, versus breaking into someone else's code to debug, and that's got the wizard hat. And so here's all of the tools that I could think of or find information on. So we have functions that you can use for debugging. You have options you can use for debugging. And then you have settings in your RStudio interface that you can use for debugging. And each of these tools does something slightly differently. So some of them are good for traceback, some of them are good for the interactive debugger, some of them are good for your code, and some of them are good for anyone's code. I tend to gravitate towards the tools that have the most icons on them, right? Like tools that allow me to break into both my own code and someone else's code easily are great for me, because then I don't have to like remember more than one tool. I can just use it anytime. And that is a lot. This grid is a lot of information. There are tools, they achieve similar objectives, but slightly differently. And people do not use all of these tools. They pick a couple that they're comfortable with, and they move forward with their lives, and they stick to it. Or maybe, you know, they'll change every now and then, but we don't have to use all of them. I'm going to show you as many as I can over the next hour or so, and let you choose what you like. So we're going to start with debugging your own code. This is code that you own, you have written, specifically a function you have written. And we're going to go over the yellow bits here, a little bit of traceback, browser, and an option. So some functions and an option. Now, when you do get into debugging, one thing that's really important is that you actually source your functions in, which is maybe perhaps not obvious. So that is as opposed to highlighting and submitting your code, and I'll do a demonstration of that. Sourcing your function in is going to give you the best debugging experience. And of course, this differs a little bit slightly than if you're writing an R package, and like then it will be sourced in depending on how you approach the problem. So I'm not talking specifically about package development land, but just like, let's say you have a script with a function in it. All right, so to demonstrate some of this, I'm going to hop over to Posit Cloud. Load all for writing packages, is that possible for debugging? I think if you're not in the package context, I don't know of an analogy for a load all. I think you would have to do those individually. Unless you like write a function to like source in an entire directory or something. Okay. So I have a demonstration folder over here. If you want to follow along with exercises or watch, it is completely up to you. And so I am going to open up the first functions in section 1. And I want to show you first what I mean by sourcing. So we have 2 functions. We have where we're just adding 1 to an input value. And then we have another function called G that's just executing function F. So in order to source this in, I'm going to click on this source button. And now these functions are in my environment. And it's important because it lets me leverage the most debugging tools at my disposal. So now I have these functions in my environment. And if I do G of 1, it's going to execute as normal because 1 plus 1 is 2, and there's no unexpected result here. But if I do G of A, I'm trying to add 1 to a character value, and it's not going to like it. So I have error in x plus 1, non-numeric argument to binary operator. So now we have a problem, and we have to figure out how to debug it. So the first tool at your disposal is a base R function called traceback. So now I'm going to execute traceback, and it's going to actually tell me some information about where that error occurred. So it tells me that it found that error in this script, the script that I named and saved that only contains functions and no other loose bits of our code, and 0, 1 my functions. And it tells me exactly the row number where that happened. It happened on row 5 when I call it f of x. Now this context of script name and row number name is not available to you if you don't source this in. So I'm going to restart R by saying session restart R. That's going to start with a clean slate because we went through those clean slate parameters. And so instead of sourcing in, what if I just highlight this and submit it in my console just to show you what happens? Now the functions are still in my environment. And now when I call G of A, it still results in the same error, but now I want to do a traceback on it. And it doesn't give me the full context that you saw before. So the full context we saw before, again, was like the script name and the row number. And now we don't get a script name and that row number is not relevant. So that's kind of the context that sourcing gives you in terms of debugging functionality. And just to reiterate, what we're talking about now is a single function in base R called traceback that allows you to detect the location of where an error happened. Questions? We will be getting to some meatier examples that give you a little bit more eye candy to look at. All right. I'm going to restart R again. Session, restart R. And clear this. I am going to source in this set of functions again. I'm going to trigger an error with G of A, and I'm going to show you the traceback of that error. All right, so I did show you, hey, we know where our error happened. There are some options you can use to get a little bit more richer information on your traceback. So this is using an option from the rlang package called error equals rlang and trace. And then just to show you the difference here, now when I trigger an error, it says, gives me the suggestion, do you want to run rlang last trace to see where the error happened? And when I do that, I don't know if I can minimize this top bar. If anyone has a suggestion on how to minimize this top bar so I have more real estate, F11, thank you. Perfect, okay. So now it gives me a little bit more context about this error. So the function g of a lives in my global R environment over here. The function f of x lives in my global R environment over here. And it tells me more specifically exactly where the source of that function is located, and also the row number and column number that was the source of the error. So options error equals rlang and trace is something that would persist for this R session. Alternatively, if you are familiar with using R profiles, you could put this in your R profile so that it would persist and be used, employed for every session that you open. Are there any questions?
Something in the chat. If you want me to read it. There's something in the chat. Can you please explain?
So I see, can you please explain the source? I've always used run. I don't know that I know the difference between run. I think let's play here. Okay, so session, restart R. What happens if I do run? Okay, so run executes one line at a time. It doesn't read in the entire script, or one chunk at a time and not the entire script. So now let's see if I run both of these interactively and then I trigger the error. I suspect you will not have the full context for that error. So yeah, so it's kind of like just highlighting and submitting it as opposed to just sourcing it in. Can you debug a simple script that doesn't include functions? We're not going to be approaching that in this workshop. And this is specifically in the context of functions. And I think you'll see the power of that as we come to the interactive debugger. So this is specifically like when you need to get into different environments. If you are not in, if you're like in a simple script, then you're working straight from your global environment and you don't have a lot of these weird interactions that you can see otherwise. But I'm happy to talk more about that at the end. If you have specific questions after we go through this. Any other questions? Okay. I'm going to just skip back over to the slides real quick. So we talked about rlang last trace, or using the options rlang and trace to get that richer trace back. And you can edit your R profile with that as well. And just for awareness, traceback is a base R function. The rlang stuff obviously comes in the rlang package, and they just work a little bit differently. So if you're like playing around with them, just note that the ordering and numbering differs between traceback and rlang functions. So the traceback kind of starts at the error and then proceeds up to the first execution. The rlang functions will start at the first execution and then go down to the error. So it's just all a little bit different, just something to be aware of if you're tinkering. All right, here we go to the fun part. So now we're going to talk about the browser function, which again is a function available in base R. So what the browser does is it does this magical thing that I'm guessing most of you have never done before, and it's very exciting, but also very terrifying the first time you do it. It opens something called the interactive debugger. The way you use it is you have to actually modify the body of your function to include a browser statement. And then we're going to do the same steps that we did before. We're going to source the function and execute the function and trigger the function execution. Oh boy, what did I, okay, see here. All right, so I'm going to go ahead and restart R with a blank slate because I'm changing things around. I am going to insert a browser statement into this function right here. So I'm just writing the word browser, open, close parentheses. I am going to save this. You can do that with Control S or File. I guess it's already saved. Okay, it's saved. So we're going to save it. Now I have my browser statement in my function and I'm going to source it. Great, nothing has happened. Nothing is different now. I've got my functions F and G and my global environment. Now what's going to happen is that anytime the function is executed, we're going to open the interactive debugger. And that is going to be regardless of whether or not the function execution results in an error. So let me show you for G of 1, which we know does not result in an error, right? We should get the numeric result of 2. But we can see how the function works internally when we do G of 1. So now we have entered interactive debugger land. So some of the ways that you know you are in the interactive debugger is on your console. Instead of having a regular caret for your prompt, you now see browse and then the brackets 1. That means you're in the browser or the interactive debugger. You also have some new console options here that we'll go over shortly. You are highlighted in the source of your function about where you are in terms of your execution. So we just launched the browser statement. That's exactly where we are. And if you look over here at your environment, you'll see what environment you're in. Now, before, when we weren't in our interactive debugger, I think it said global or global environment there. We can go back to our global environment if we wanted to, but now we're inside of our function environment. And it shows you what exists inside of our function environment. The only thing known to this function is the value of X. And we also have a little bit of traceback information here that I don't use that often, to be honest. Okay, so what are some things that we are going to do now that we are in our interactive debugger? We're just going to run our code like normal, right? Like I know I see something called X there. What if I want to know what the value of X is? I can submit that in the console and see, well, the input value of X was 1. What if I want to see, like, you know, what the structure of X is? Or what if I want to see everything in my environment? So the console functions the same when you are in the interactive debugger. It's really a place where you can explore what's happening inside the context of that function environment. As you're ready to move on, so this browser statement executed at the top of the function. As you're ready to move on, there are certain keyboard shortcuts you can use. And I'm telling you these because maybe not everyone works in the RStudio IDE and doesn't have access to this console here. So you could use the keyboard shortcut in to go on to the next statement. Now the next statement is actually going to end the function call because it's going to do 1 + 1 is 2, and it's going to stop and return that. So once I hit in, we're going to be exiting our debugger or interactive debugger. After I hit in one more time, we're going to exit. There we go. Okay. So we've executed the x + 1 successfully, and we got a value of 2. And we have exited our interactive debugger. Now, I can do this as many times as I want to. What if I want to do this for an error this time? I'm going to submit a value of A, which I know results in an error. And I want to figure out why the heck this results in an error. So I can use ls.stir, which lists all values in your environment and their type. And so now we see, A is a character value, and that is probably why I'm getting this error when I try to add 1 to it. I'm going to hit in for next, and now the function has exited on an error. Questions at your first exposure, possibly, to the debugger?
What does the first browse one line does? What is this debug and the first n that you type? The following, yes, this one.
That n. So that n means move on, execute the next line. So when we call this, so it opens the browser statement. I'm going to hit in, which will move that yellow highlighting to the x + 1, but not execute it yet. So I'm going to move the active line to x + 1. That's the first in. The next in is to move to the next line, which will execute x + 1. Other questions? Can I change the x value when inside the debugging? Interesting question. All right. So here, I know my value of x is A, and I want to change it to be 1 and see if it works. And now I'm going to confirm x is now a value of 1, and I'm going to hit in, and I'm going to hit in again, and now it works. So yeah, it's just a regular R console. You can do whatever you want. Great question. Are you also talking about the arguments of browser? What are the arguments of browser? That's a great question. I've actually never looked at the arguments of browser. Let's save that for another time. That's great. Never used it, but now I'm curious to learn more. Thank you. I recently discovered EXPR, and it's really great. Recommend it. Okay, at the end, let's talk about how you're using that. I'm very curious. Is it also possible to track back after the error occurs so I don't need to run all the code again? Great question again. This browser statement can go anywhere in your function body. So it can go in line 1, or it can go in line 100. If you place it in line 100, it means it will go ahead and execute the first 100 lines for you, and then kind of walk you, open up straight at that point in your function. So you don't need to run all your code again. Other questions? All right. So when you're using the interactive debugger, some functions that are really helpful to use are ls to list all objects in your function environment, ls.stir to also list their types, or just figure out the type and structure of individual objects with stir and print. These are all helpful things to do. In terms of controlling execution of the debugger, we used in as an illustration there. And other commands that work are C for continuing, S for stepping into a function call, F for finishing, and Q for quitting the debugger. And then these also align with the console that you saw, and I'll talk about that in the next section. So we've talked about traceback and browser, essentially. Now it's time to go to our first exercise. So I'm going to walk you through a little bit of the first exercise because it's a lot, and then you all can take a vote on if you want time to work independently or if you want to do it together. So okay. So I'm going to close my functions. I'm going to restart R. Going to just clear this to make sure everything looks clean and easy to see. And then go back up a level to 0, 1 exercise. You're going to see 4 files here, and they relate to how many hints you want. So comfy, let's start with solution, which is what I'm going to open, kind of walks you through with the most detail possible. Comfy has like a little bit more minimal details, and Spartan is like very bare bones. If you want to challenge yourself and you've done debugging before, you might want to open that. So I have the solution opened. And the first thing that we're going to do is we're going to source, which is equivalent, using the source command is equivalent with clicking the source button. The 0, 1 source me, which has some functions inside of it. I am not at the top of the script. Hold on. Let's restart R. Okay. Let's take a look at this script first. Okay, so I'm going to open and inspect and review this code. So here's the source me function. What source me has in it is it has a data frame with some information about some fruit, and it has a function called fruit average, which computes an average of some sort regarding those fruits. So we are going to now source that in, and we're going to take a look at our fruit data. So this is the fruit data that was input. We have blackberries, blueberries, peaches, and plums. We have some features of those fruits: calories, weight, and yumminess. And what we are going to do with fruit average is we're going to take some averages of it. So let's say we want to average out everything that has a berry in it. Now we can see the average calories for the berries is 2.5, the average weight, and the average yumminess factor. But we get some sort of weird error when we execute on it. Hold on. Did I? Yeah, I fixed it. Okay, sorry. Let's take this out. I don't know if it was in everyone else's workspace. That's not supposed to be there. Y'all are gonna have to tell me what happened. Okay, so I'm going to restart R. Okay, I'm going to resource that in. I'm gonna take a look at our fruit averages. Now, when you execute this, you should see an error. Found blank fruits, error in row means mini-dot, X must be an array of at least 2 dimensions. Are you seeing the error, or are you seeing a successful execution? Because if you're seeing a successful execution, I'll tell you what to delete. Oh no, okay. So you got a copy of the workspace that I had fixed. Oh yes, there is a file called solution. Well, now we've just spoiled it for everyone. Okay, what you saw in this, if you want to, you do need to experiment with the error in place. And so if you are on line 11 and your 0, 1 source me, you want to delete this drop equals false. So just take it out, and then we're going to experiment with the error, and then we'll come back. So I'm just going to, on line 11 and 0, 1 source me, gonna remove the solution that you are not supposed to have. And I'm very sorry for this experience. It's supposed to be a little bit more mystery for you. So, all right, deleting. If anyone needs me to repeat that, I can repeat that, and just let me know. All right, I'm going to restart R. I'm going to go back to the top. I'm going to source in my source me file with functions, take a look at things, and I confirm that I have an unexpected error. I had no idea this was coming, but yay, now I have an error. Yes, exactly. Now we have an error, and that is the whole point of this. How are we going to debug our errors? So the first thing we're going to do, we're going to look at the location of our error. All right, so tells me if I look at row means mini dot, like something weird is happening right there on line 13. So we're on line 13 at row means, that's where the error is happening. All right, not quite clear why, but that's where it is. And we can take a look at our richer traceback if we change our options to rlang and trace. So now it's giving you the suggestion to run rlang and trace. And we see a little bit of more context here, right? And I really love how this prints out, because it says in your global environment, we have this function called fruit average. So fruit average is actually calling row means function, which is a base R function. So it's giving you that context about what package that function is in. And the place where that execution happened gives you the exact row and column of where that execution happened. All right. Now what we're going to do is we're going to modify the body of this function. And we're going to do so by putting a browser statement in. Again, I can put a browser statement up at the top, and it'll be opening the function without any of the lines below executing. So I'm going to save this now, and I'm going to source it in. All right. Now, instead of triggering the interactive debugger, I'm going to go off script a little bit, and I'm going to, instead of triggering an error, instead of triggering the interactive debugger on an error, I'm going to trigger the interactive debugger on a successful execution. So we know that Barry worked, but I'm going to open up the interactive debugger in a situation that I know works on berries. All right. So we're starting at the top of our script. We know that this fruit average function took on 2 arguments, dat for data, in some sort of pattern. What are the values and types of these? Let's do ls.stir. So we know we have a data frame with 3 observations and 4 variables. And we also have a pattern that is a berry string, a character string with a value of berry. Now I can step through this function within. So I've highlighted the next line, but I've not actually executed it yet. So now let's execute calls. So now I can see that the value of calls is a vector, which contains values in 1 and 2. And now I want to reduce my data frame to only those that match the pattern of a berry. So I'm going to subset my data into something called mini-dat. So I'm going to do in for next again. And so now mini-dat exists, mini-dat, and it's just keeping the blackberries and the blueberries. Now I'm going to hit in again. And now I know that I found 2 fruits, and that was the messaging statement. Now I'm going to hit N again to execute the row means, and you're going to see the successful execution and the end of the function execution as well. So now we have computed the average among berries, and we know everything worked out great. Now we know from our traceback that really where the problem is in this row means. So maybe if we wanted to use that information from our traceback, we could move the location of our browser statement to have everything above that browser statement already executed for you. I'm going to restart R. I've moved the location of the browser statement. I'm going to source this in, and now I'm going to redo a successful execution. So now everything before that browser statement has already been executed, so I don't have to go through it step by step. Now I can spend some time investigating my objects before I move on. Like I can just copy and paste some code. Like, does incall of minidat work? Yeah, like it gives me a value of 2. And like, what is like the dimension of minidat? It's a 3x2 matrix or data frame. So, so that's what's happening on a successful execution. Now your turn is to investigate what's happening when we stump a peach or result in an error, and see if you can find the root cause of the problem. Put something in the chat if you want me to do it, or something else in the chat if you want to do it. So put me in the chat. Wait, put Shannon in the chat if you want Shannon to do it, or put me in the chat if you want to do it yourself. And so do you want to do Shannon or me? Like you do it or me do it? All right. Viola, you want to turn playing around by yourself? Go for it. All right. So I see a couple of me's. So I'm going to give you all time now, a few minutes to play around. I want you to trigger that error on Peach and see if you can figure out why Peach is resulting in an error. I'm going to give you some time to go for it. Let's say 5 minutes or 7 minutes. Let's say 7 minutes. So you may start now. And I'll count down until 8 on this clock. All right, so I think I will go ahead and come back together now, unless anyone has any strong protests and really wants more time on their own. So did anyone figure out why Peach results in an error? What is the root cause of the problem? Not a data frame. That's right. So let's open up this. And before I do, I want to point out there was another comment on the chat that it's a really nice example, and I forgot to read this line to you. This isn't my example that I came up with in my own brain. This example was actually used in Jenny Bryan's keynote talk, so it is borrowed from her keynote talk. So you will be very familiar with it when you watch it. Okay, so let's, yes, exactly, Abdul. So in case you didn't quite get a handle on what happens when we try to do this for Peach, let's get a handle on it. So what's happening here now is our input data with the data frames, 3 observations and 4 variables, are columns that match that Peach pattern of interest is column 3. And when I subset the data to create minidat, and I subset it on column 3, now minidat becomes an integer vector instead of a data frame. So before, when there was a successful execution and we had the 2 columns with berries, when we subset that data frame on 2 columns, it resulted in a data frame with 2 columns. However, we have some interesting default behavior when we subset on a single column. And when we subset on a single column of a data frame, instead of returning a data frame, we're actually returning a vector. And because we're returning a vector and not a data frame, and let's just like prove to ourselves, right? Like, so mini.dat is an integer vector, not a data frame. Because we're returning that vector, when we try to execute row means of mini.dat, now we are going to hit that problem that we really wanted to see something with 2 dimensions because we have a vector with 1 dimension. Okay. And so as you saw, unfortunately, already what the solution was, we can formalize that. There's the secret fixed root average.r document, kind of details what's going on here. And then all you need to do is in that function that does the subsetting, add this argument for drop equals false. Now I'm gonna restart R. You can do that from the menu or from Control-Shift F10. So I've restarted R. I'm going to resource this in. I guess I'll just leave my browser statement in there. And now when I have the drop equals false argument, you can see mini.dat is now a data frame of 3 rows and a single variable instead of a vector. Okay. Are there any questions? All right, so we've used our browser statement. We successfully found the root of our error, diagnosed it, and all of that. A drawback to this, like you have to remember to take it back out of your code, right? Like now we're done, so you have to remember to delete it from your function now that everything is fixed. So of course there's other options. Any other questions before I move on? We're going to do the same exercise, but with a slightly different format, and I'll show you in some things that you can do in RStudio. So we're going to be talking about breakpoints and some of your error inspector options. Have you ever put this little red dot by your script? I'd had like no idea what it was doing or why it was there, because I certainly have. This red dot is called a breakpoint, and it is equivalent to a browser statement. That's all it does, is it puts a pause or a breakpoint in your code. And so an advantage here, as opposed to inserting the browser statement, is that you don't have to change the body of code for your function, but you do have to remember to like turn that breakpoint on and off again. So the way you do it is you just click to the left of those numbers to turn it on, and click to the left of numbers again to turn it back off. So it's just the same as a browser statement. It's going to launch that interactive debugger. So the left of the numbers is called the gutter. And you know the picture of slide 27 is not in the slides for us. Slide 27. This picture? You can't see this? You see this graphic with like the... What? Like on your local computer or when I'm screen sharing? Okay. Something interesting for me to figure out. Okay. Okay. Weird. People say they can. Okay. Let's get to the bottom of that as well. Thank you. So let's talk about some IDE options. All right, we've got our breakpoint. And so what you saw when we were using the debugger is that we saw this console that I kind of just glossed over. It does the same things as those keyboard commands, the N, the Q, the S, and all of that. So you can just point and click if you're using RStudio IDE. And then let me demonstrate the debugger using the breakpoints just real quick. So I'm going to close out all of my stuff. Restart R. I'm going to go back over to the demonstration folder. I'm going to go to my functions. I'm going to activate my breakpoint. So this red open circle over here indicates that the breakpoint has not yet been activated because I have to source this file first. So again, I am in demonstration and then in 02 my functions. I'm going to source this file. Once I source this file, my breakpoint has been activated, and you can see that with a red circle denoted on that function in my global environment. And this is just a slightly different example than what we were using before. So now if I want to do an operation where I split a string, sorry, let me take off the breakpoint real quick. So the breakpoint's off, and I'll just show you what this does. So G of A comma B results in this split string where it's split on the value of the comma. But if I input this as a factor instead, we are going to get an error because it's expecting a character argument and not a factor argument. Or specifically string split is expecting that. So if I want to do some debugging, I can use this breakpoint, which is the red circle. Now, when I execute my function, either for an error or not an error, remember debugging are good for both. The interactive debugger is good for both situations. I'm not expecting an error here, but I can still get into the body of my execution. Now, one thing that we didn't talk about before is the difference between next and step into. So next kind of just executes your function line by line, but step into allows you to do a little bit more magic, right? So instead of executing string split, it's going to step into the body of string split, even though we didn't write string split, and string split is part of base R. So let's step into this, which is honestly very confusing and probably better suited for some other examples. But it's just that step into functionality is really nice as well. All right, let me see where I was on my slides. Okay, so we put on a breakpoint. There's also these options that you have in the RStudio IDE beyond the breakpoint. So there's this debugging menu at the top of the IDE, and there's options that you have for on error, and it's probably yielded some confusing results for you at some point because on your local computer, I don't know if you have set it to message only, error inspector, or break in code. But if you ever see like unexpected results, it could be because your on error got accidentally like reset to something else. So here's that setup that we just did with the breakpoint, and saw that we had the error with factor. So let's see what happens if we do the message only option. Sorry, I keep hitting escape and it keeps going back there. Okay, so I'm going to take the, I am going to take the interactive breakpoint off. I'm going to restart R. I am going to see what my debug on error settings are. So again, in my IDE, if my Zoom menu will move, I'm going to debug on error. And right now it's set to message only. So that means when I get an error, I'm only going to see the resulting message from that error. So I'm going to source in these functions. I'm going to trigger an error of factor A, comma, B, and I just have my messaging. Now, when I go to debug on error and error inspector, in theory, I should have a different result. I don't know if in practice I do. I'm just positive thought in my mind. Oh, yes, I do. Okay, here we go. So now the error inspector results in something slightly different. So instead of just printing the message, it gives me two options. Now I can show the traceback, or I can rerun with debug. So show traceback is the exact same as the base R traceback function. There it is. It's what you would have expected to see. And rerun with debug is what opens the interactive debugger at the point where that error is triggered. So you can click on rerun with debug here and launch that interactive debugger. And where that interactive debugger opened up is in the middle of the string splits function, which like you didn't write. It's part of base R. And you probably have no idea what any of this is because, well, if you do, I don't. So we have now used our error inspector option in the RStudio IDE. The last option you have here on your debugger is break in code, which means that anytime that error is triggered, it will automatically open up the debugger at the exact point where that error was triggered. So again, in the middle of the string split function, which can be honestly like a little bit hard to jump into if you didn't know that's where you came from or where you're going. So if you ever have seen these gray boxes pop up and you're not sure why they pop up or when, it's because of your debugging options in your RStudio environment. And I'm going to set mine back to message. And just a small note on your error inspector in RStudio, it's only invoked if it detects your code. And I don't want to get into the nuances of when it's triggered or when it's not, but like if it doesn't detect enough of your own code, it's not going to get triggered. So we talked about IDE options with breakpoints and your error inspectors and breaking in your code. So now it's our turn to go through the 0-2 exercise again. But I want you to do something, you're going to see a slightly different setup. And I want you to do something slightly differently this time. Let me orient you to the setup. So in our 0-2 exercise, I'm going to open up the solution again. I'm going to verify that you don't actually have the solution in here. Okay, no, we're still going to hit an error. Yes, there is no solution in here, but there's a different setup here. So the different setup in this instance is before, when we did 0-1 source me, we just had one function to walk through. Instead of one function to walk through in our 2 exercise, we have a series of very small functions. And the reason why we have a series of very small functions is because I want you to experiment with that step into feature, because that step into feature is very powerful for figuring out where things go wrong and like understanding that you can actually do that. So now we have a series of smaller functions composing a larger function. So I am going to start at the top of the script. So we've looked at our source me. We are going to source it in. We're going to verify that we have some fruit data. We are going to do a successful execution for berry. And then we're going to see an unsuccessful execution for peach. And now I'm going to give you a few minutes to work through this. But I really want you to practice using the step into function. And I want you to practice using the breakpoint option. So I want you to figure out where you want to put your breakpoint. Do you want to put it here? Do you want to put it here? Source in that function with a breakpoint activated on it. And as you go through that execution, practice stepping into things. That can be achieved by executing the character S will allow you to step into functions, or alternatively, using this arrow into the brackets will allow you to step into different functions. So here I stepped into reduce stat. So now I'm going to give you 7 minutes to play around and experiment. And you are also welcome to drop any questions in the chat. Some RStudio IDE features. So just, I'm going to restart R and start through a little bit at the top here. So I've opened the file, I've sourced it in, I've viewed my data, I've confirmed it works for berries, I've confirmed that we hit an error for peach. We've looked at our traceback, we know exactly where it happens, we know what happens if we do our modified traceback. Let's run our line glass trace. Now when we look at our modified traceback, now that we have this like one larger function composed of a series of many functions, it'll tell you exactly, that traceback will tell you exactly every function that it goes through in order to hit your error. So first we started with the fruit average function, then where we started to enter our error was in that compute average function, and then that compute average function called the base R row means function, which is where we hit our error now. So we're going to open up our interactive debugger, or launch our interactive debugger by pressing, by activating a breakpoint with a red column, with the red dot. Again, that red dot can go anywhere in the body of your function, depending on what you want to have already executed. I can source this in by either clicking on the source button here or using the debug source command now in order for R to read that breakpoint. So now I can trigger that interactive debugger by calling fruit average. And I've stepped into the body of my function. And remember, the challenge here was to, still explore what you have in your environment and figure out what's going on, but just to do it a little bit differently by stepping into the bodies of functions. So now I'm going to step into the body of find calls, and we can see what happens when we execute find calls. So find calls is going to find which columns match that pattern. So we can step into this function environment, and now we can see what's going on, what's available to us in this function environment, which has data and a pattern. We can execute this with next. And now find calls has successfully executed. I'm back to my primary function of fruit average. And now I'm ready to execute minidat. I can execute minidat just by hitting next and kind of skipping over the details of what happened there, or I can step into minidat. I guess, what was it? I mean, reduce that, which creates minidat. So now I'm stepping in to reduce that. I can see what's available here. So I can see like, what do I have in this function environment? So I know I have a data frame that I'm going to subset or reduce based on column 3. And when I do that, I'm just gonna go ahead and click on next and execute this line. Now the reduce data function worked to create minidat, but here we still have that problem where minidat is a vector. I'm going to click in to execute that message. I probably actually should have stepped into it, right? Because here we find this weird thing that it found no fruits or a blank number of fruits. And the reason why it does that is because it's trying to figure out the number of columns of minidat, and minidat is a vector and it has no columns. So that's why you get a null value for a number of columns. And that's why you get this weird messaging here. And now I'm going to step into compute average. And then I'm going to step into row means. And when I step into row means, it is a little bit more informative than that string split example that we looked at, but it's still like not easy to read. Here we have a base R function, and you can stare at it for the rest of the time we have and still be digesting it. But we can step through line by line of this base R function, and notice how cool this is. Like, you just got into the source code of a base R function. You did not write this. You stepped into the body of it. And so we can kind of still kind of, it's what's a little bit trickier there because we don't own the source code. Like the highlighting isn't as exact or precise to kind of show you where you are in the body of the function as you're going through these executions. So I did hit next a few times, and here we have hit our error. X must be an array of a couple of dimensions, at least 2 dimensions, and that's the error that we see out of our row means function. Just to kind of contrast that with what might happen if you change your debugging options over here, I'm going to remove this breakpoint. I'm going to restart I'm going to source this in, going to change my debugging. Okay, sorry, my Zoom panel keeps blocking me. Okay, to on error, and then I'm going to change it to error inspector so you can see what happens. So now let's trigger something here. Did not expect that. Expected a little bit. I expected the gray box there. Did not get the gray box there. Let's see what happens if we break in code. All right, so debug, on error, break in code, fruit average. All right, so just to kind of show you what happens when you break into that code, as soon as that error occurs, it drops you straight into row means, which if you have no idea how you got into row means, it can be very disoriented, right? Because you went through like 5 or 6 steps to get into, all right, I am not asleep. I am actively executing this project. What is happening? All right, but you did go through like 5 or 6 steps to get into those row means, and what that on error did is it dropped you straight into row means, which I can find quite disoriented. I don't know what's happening here. All right. And let's see where we are. Debugging on error, break-in code. Let's source this guy in and just show you again. So now that I'm on break into code, and now I've just stepped straight into row means and left to fend for myself in base R. All right. So I'm going to put my debugging back to message only. Are there any questions about these RStudio options? We talked about the breakpoint. We talked about changing your debugging options, and we talked about navigating via the console. All right, got 10 minutes left. We're going to do this, people, because we got to get to a couple more really fun functions. Debugging their code. What if you don't own the source code? What if you didn't write it? It's not in your script. It's not in your package. You don't have access to it. Obviously, you can see we can get into it, right? Because like you just saw, we stepped into like base R. But what might be some strategies you use? So we're going to talk about the debug and debug once functions. So there is another function you can use called debug. Debug is the exact equivalent to using either a browser statement that you write into your function body, but you can't do because you do not own the source code. So you cannot modify the function body, or putting a breakpoint on the first line of the function, which you can also not do because you do not own the function body. You're trying to break into someone else's code. You can't modify the body of the function, or you can't leverage the breakpoint in a script. But debug will open that interactive debugger at the beginning of execution. Now, what debug does do is it keeps you in debug land forever until you remember to turn it off. So when you are debugging a function G, it is very important that you also remember to undebug that function G. So what it's going to do is that interactive debugger is going to start every time G is executed until you do undebug. I have not personally had this experience, but I've heard others that sometimes they get trapped as a debugger when they use this because of the, I don't know, because of the way it works. So let's go show you. All right, we're gonna get out of these examples. I'm gonna restart get a fresh environment. I'm going to clear my console. I'm going to go over to project demo. I'm gonna go to my functions. I'm going to go to execute. I'm gonna try to remember what I am doing. I'm debugging, that's what I'm doing. Okay, so my functions are back to the beginning functions, just x+1 again. So I'm going to source in that script. Now I've got my functions f of g. I'm going to set my debugging flag. So I am debugging the function g. Now I'm going to execute function g. Now I am in my interactive debugger. It looks different, I think, than before, possibly. I can't quite remember now. It did look a little different when I called it, right? Like I think before it was opening up this script and showing you the interactive debugger as you walked through this script. The debug function works either on your own script, like on your own R function, or functions that you don't own, like that you don't have the source code for. So it does look a little bit different. We can step into this function now. We can, and I clicked on the step into button there to see that we're actually trying to do x+1, keep stepping in, keep executing, and then we result in our error. But now just note that like every time I call the function, every single time, it doesn't matter if I'm getting an error or not, See, I'm calling G of 1 now. Every time I call the function, I'm executing the interactive debugger. So in order to turn that off, you have to say undebug that function. Now, I can call that function as usual. You have to remember to undebug it. As an alternative to debug and undebug, there is debug once. Debug once does the same thing. It puts that, it's like executing a browser or a breakpoint in the first line of function, but it does it one time only. So you never have to remember to undebug it. But you do have to, if you need to keep going back into the function, you have to keep resubmitting debug once. So you would do that very similarly. I'm going to restart R for good measure. I'm going to source in my functions. I'm going to debug G one time, debug once. I'm going to call my function. I'm going to walk my way through it. Going to get my error. And now I'm done. Now when I call G again, I'm not opening the debugger again because it was only triggered to debug one time. We have 5 minutes left. I just want to mention that if you need to debug code that's not your own, and you want to do it somewhere beyond the first line of code, so you can skip over a million steps, you can do that with the trace function, specifying what step you want to start at. All right, just so you can see how this works in our last few minutes, I'm going to go over to exercise 3. I'm going to open up the solution. And this is a different setup again, because now we don't own the code. So what I have done here is I have created a package called WTF debug. You do not need to execute this line. You do not need to install this package. This package should already be pre-installed in your POSIT Cloud workspace, which you can test by executing library WTF debug. We can look at our WTF debug package. And you can see it's a very small package with a fruit average function and some fruit data and all of those little mini functions that compose the bigger function. So we do not own this source code in the WTF package. It lives in someone else's package now, and we need to get to the bottom and figure out why on earth we can't compute the fruit average of peaches. So fruit is in there. The fruit average works on berries again. On peach, we're going to get that error because we've got a bug in our code. We can still identify the location of that error. We can still use our options for our richer traceback. Now you notice this looks a little different because this function lives in the WTF debug package, no longer in our global environment. So that's signaled in our traceback. And now I'm going to use the debug once function to trigger the interactive debugger because I cannot modify that function body with a browser statement, and I cannot set my interactive debugger or my interactive breakpoint. So now I'm going to trigger. I can't remember if that needs to be in quotes. But it worked. Okay. And so now I have triggered the interactive debugger a single time. It has brought me into the source file for fruit average. And now I can use my interactive debugger tools to step through things. So I can kind of walk through just as I would any other function as if I owned it, and see and try to diagnose what's going on. Again, we see that vector problem. All right. So debug should not require a source call, as I'm not expected to have a source, right? Yes. Debug does not require the source call. All I did to kind of source it in, for lack of a better words, is say, like, I attach it, library WTF debug. So that made that function available to our workspace. So yeah, we don't need to source it in. All right, it is 1 minute. I can stay on for a few questions. I'm happy to take any. Thank you all for joining. I hope you got something out of this. Like putting in the browser statement? Do you like using the red circle breakpoint? Do you like using debug or debug once? I mean, it is the most powerful when you're in the context of working with functions. So, and I think it's especially really powerful when you're writing your own functions from scratch, and you just kind of, you're tinkering and you're hitting new situations and new errors that you're not quite sure how to resolve. I use the debuggers on my own functions and develop, or like, I guess like not in development, like, so I'll have written a package internally, I'll have released a function, I think it works great. And then all of a sudden I'm actually using it on a live project and something unexpected happens. And that's something I didn't really think about, you know? And then that's when I go into my interactive debugger and I say, what is this weird thing that is happening? Why is it happening? And then that allows me to inform a modification on my release package. So I can go back in and modify that function to be more flexible or approach those errors. All right. Well, thank you all for being a great audience.